is on 626. This is the example, and then we'll jump to the problem itself. Tangent's a little bit fussier. And so I'm going to show you what all this means. It's a little bit hard to follow. But they're saying, all right, we've got this equation that we have tangent of 2x minus a third equals 1, right? Well, think about that as just like tangent of some angle equals 1. And that angle, well, it's going to have to be up here, like pi fourths, right? It can also be down here at 5 pi fourths. Okay, so I think we've seen from before that we can say that this inner mess should be equal to, so this 2x minus pi thirds, that should be equal to pi fourths, or also 2x minus pi thirds should be equal to 5 pi fourths. And that's a good way to find two of your solutions. So we got these sites by looking at where this this tangent of this angle equals 1, when that's true. It happens here and here. So what we're going to do is try to find a minimum and a maximum and like go through them and try to find every time this happens and just count them off. And then we'll do this same process with each of those. So we're going to find a whole bunch of these, right? So let's give that a shot. First we need to know where to look, right? So let's look, let's do this. I know that we were going to go from pi, negative pi to pi. So negative pi to pi. I want to find my minimum and maximum value that I have to start looking in. So first of all, I know that I'm going to double whatever this is. So this is going to be, so our maxima are going to double as well. Right, so I just, since we dropped a 2 in here, this gets doubled and that gets doubled. And then we also have this piece, so if we're dropping that in here, so as 2x minus pi thirds, so all I'm doing is looking at how this domain is shaping our x. We're going to do the same thing here. So this is going to be 2 pi, so that's like 6 pi thirds, and then we're going to subtract a pi thirds from that, right? I'm just taking this, subtracting this from this. Okay? So that should give us a 5 pi thirds. So whatever that inside value, it can go up to 5 pi thirds. That's not talking about our x, it's just talking about the inside value. We're going to do the same with this. And so this is negative 6 pi thirds. And because of this, we're going to subtract another pi thirds from it. So you end up with 7 pi thirds. Yeah? All right. Let's get rid of those. Okay, so all we've found is like how far down do we have to look for these interesting angles, right? And then also how far up. So let's start by looking at from 0 up to 5 pi thirds for these interesting angles. So I'm going to try to, well, let's make it. Let's do the same thing. I know that this interesting angle happens at pi fourths and at 5 pi fourths. And 5 pi thirds is going to be, here's pi thirds, here's 2 pi thirds, here's 3 pi thirds, here's 4 pi thirds, here's 5 pi thirds. So we're not quite all the way around once. So let's count where they end up. So here's pi fourths, so that's one of my solution, or one of my solution starting points. Here's 5 pi fourths. There's another solution starting point. And then I run out of space. Okay, so that's for 0 up to 5 pi thirds. let's go from 0 down to negative 7 pi thirds. Right, that's this part. So let's see, let's find where 7 pi thirds is. If we go backwards, 6 pi thirds going backwards is here, so one more would be 7 pi thirds would be there. So, oops. So this is 7 pi thirds, but negative. Okay, so let's find out where we run into things. So here is, this would be negative 1, 2, oh, I guess this would be negative 1, 2, 3, negative 3 pi fourths. Then keep going. So this would be negative 3, 4, 5, 6, 7, and negative 7 pi fourths. So those are all starting blocks, right? Just like we did up here when we said, oh, well, let's just substitute in pi fourths and solve for x. We're going to do the same thing, but we're going to do it with these 4 solutions. Before, we just did it with these 2 solutions. We're going to do it with all 4. So we are going to take this thing and set my solutions equal to each other. And so we're going to do this. Say, okay, let's see when this equals this one, pi fourths. And we move the pi thirds. We're going to have to multiply to get a common denominator. This is going to end up being 7 pi 12ths. And when you divide by 2, this ends up being 7. So x ends up being 7 pi 24ths. Yeah, if you need to pause me and check my fractions, go for it. We're going to do the same thing for this, but we're going to use 5 pi fourths, right? So this is 15 pi 12ths, and so you would get, so 15 pi 12ths, and then you're going to add another pi 12ths. I'm totally looking at the wrong one. Yeah, you're going to 15 pi 12ths, and this is 4 pi 12ths. So this is 19 pi 12ths. That's not even 19 pi 12ths, and then when we divide by 2, this is 19 pi 24ths. You can definitely check my math on that. You're going to go through and do the same things with these two, and you find your other solutions are 7, we already got that, so negative 5 pi 24ths. You get from one of these doing the same thing, and you get the x's negative 17 pi 24ths from the other one when you do the same thing. Cool? So there are your solutions. I'm going to come back and try number 7 with you, 7b. We'll check that out together. Okay.